So in the previous videos we were discussing about the odd occurrence problem, and let me tell you that this is also a very interesting problem. Now in the first two videos we have seen the solution by using the for loop. The time complexity was not up to the mark. Then we discussed the solution by using the hash table. Now in this video we'll be discussing the solution of exactly the same problem, but this time the solution is by using the XOR, and clearly I can say it is a bitwise XOR. And let me tell you very clearly that this is one of the best, smartest solution that can be possible for this particular kind of problem. Now what is the solution by using the bitwise XOR? There's a few properties of XOR, and when I'm saying bitwise XOR, there are a few properties which are really very interesting. Number one is XOR is commutative. XOR is commutative. That means if we have A XOR B, that can be written as B XOR A. And second property is that XOR is associative. That means if I write A XOR B XOR C, that can be written as A XOR B XOR C. So it is associative. The third property is that if you do A XOR with A, then you are going to get 0, but if you do A XOR with 0, then you are going to get A itself. Now assuming that we have a few numbers like this, we have this the first number, which is 2, we have 1 2 4 1 4 2, like this. I've just taken a very small array so that it will be easier for us to follow this one. Okay, now what I'm going to do is, let me just assume that these, instead of 2 or 1 or 2, I can mark them as characters for simple understanding. I can okay, let me do it this way itself. So what I'm going to do is, I'm going to take this 2, and we can take 2 XOR with 1. Okay, I can take this 2 XOR with this 1, and whatever the result will be, I can XOR that result with this 2. Okay, whatever the result will be of these XORs, I can XOR of that result with 4, and after getting the XOR of these numbers, whatever the result will be, I can XOR with 1, I can XOR with 1, and whatever the result will be, again I have to XOR with 4, and whatever the result will be, I have to XOR with 2. Okay, and why it is a very smart solution is because we are using these properties of XOR, which is that XOR is commutative as well as XOR is associative. Now because XOR is associative, therefore actually we can remove these brackets. That will be a much better way of writing this entire equation. So this entire equation can be written as 2 XOR with 1 XOR with 2 XOR with 4 XOR with 1 XOR with 4 XOR with 2. This is the associative property. That is why I removed all the brackets. And next is the commutative property, which makes it more interesting because I can just change their positions. For example, I can swap these two values, so it will be 1 XOR with 2, again XOR with 2, XOR with 4, XOR with 1, XOR with 4, XOR with 2. Now 2 XOR 2, this is actually 0, correct? So I can do 1 XOR 0. Okay, and I can swap these two numbers also. I just solved this one. Now I can swap these two numbers also, so I can do XOR 1 XOR 4 XOR 4 XOR 2. 4 XOR 4 is also 0, so this can be written as 1 XOR 0 XOR 1 XOR 0 XOR 2. Now again I can apply a commutative property here, or I can apply a commutative property here. So it can be written as 1 XOR 0 XOR 1 XOR 1 XOR 0 XOR 2, and this XOR will be 0, so it will be 0 XOR 0 XOR 0 XOR 2. Actually all these XORs can be written as 0 itself, so it is 0 XOR 2, which is 2. Therefore by the end, if you get a number which is not 0, clearly you can see that we are getting a number which is 2. If you get a number which is not 0, that means this number is occurring odd number of times. And because of this property of XOR, if any number is occurring even number of times, then those numbers will be cancelling itself. For example, if 1 is occurring even number of times, then if you do XOR of all those ones, the result will always be 0. But if 1 is occurring odd number of times, then if you do XOR of all those ones, then you are going to get a number 1. So this is a very interesting solution, because just by using a bitwise XOR of every number, you can make it so it's becomes so easy to find out a number which is repeating itself in odd occurrences, right? So this is also very, very interesting solution. And if you don't know what is an XOR, let me just tell you how do you do XOR 2 XOR 1. I mean, if you have a number 2, if you do XOR with 1, and if you have a number 2, if you do XOR with 2 itself, then why the solution is 0 or 1. In this case, you can write 2 like this. We have 0 0 0 0 0 0 1 0, and you can write 1 as 0 0 0 0 0 0 0 1. So if you do XOR of both of them, then XOR says that if you do XOR of these two numbers, you are going to get 1. XOR of these two numbers, you are going to get 1, and all the other bits are 0. So again you get a number. But if you do 2 XOR 2, that means 0 0 0 0 0 1 0 0 0 0 0 0 0 1 0. So it will be 0, and because these are 2 or 1, so we are going to get 0, and so on. Okay, you know the properties of XOR operation. XOR property says that if you have 0 XOR with 0, you are going to get 0. 0 XOR with 1, you are going to get 1. 1 XOR with 0, you are going to get 1, and 1 XOR with 1, you are going to get 0. So because of this property of XOR, whatever the result will be, if any number is occurring odd number of times, that number you will get in the end after performing XOR of all the operations. But if no number is occurring odd number of times, every number is occurring even number of times, then definitely you will get a result as 0, and hence you can say there is no number which is occurring odd number of times, right? Actually this is also very intuitive, because if this total array, the size of this total array is odd, that means for example it is 1 5 3 or whatever. If the size of the total array is odd, then there must be any number by the pigeonhole rule that which is occurring odd number of times. But if the size of this total array is even, then there might be a number, there might not be a number which is occurring odd number of times, that we have to find out. Now let us see the programming solution. Let us write a program to perform this bitwise XOR and the hash map to solve this problem. Okay, let us move on to the next video, where I'm going to write a program to solve these problems. Okay, thank you for watching.